Support handout number 10. Problem number 1. In each case, we've got an angle. We know that it's an acute angle, which is very helpful. And we want to find that angle by hand given the trig statement that is provided. So part A, I know that cosecant of my angle is equal to 2. I think I'm going to put a 1 under that to make it look like a ratio. I know I'm drawing a first quadrant triangle picture. Let's see, cosecant is the reciprocal of sine. So if cosecant is 2 over 1, sine would be 1 over 2, opposite over hypotenuse. We're doing this by hand, which means they must be giving me one of my special triangles, and of course they have. It's just the 30, 60, 90 triangle here, which means my angle is 30 degrees. They want the answer in radians, and so I will write pi over 6. Part B, the secant ratio is root 2 over 1. Again, I know I'm in the first quadrant. Secant is the reciprocal of cosine, so the cosine ratio would be 1 over root 2, adjacent over hypotenuse. Of course, this is just our 45, 45, 90 special triangle, which means my angle is 45 degrees, or in radians, pi over 4. And finally, another first quadrant angle, cotangent. Let's see, cotangent, reciprocal of tangent. Tangent's opposite over adjacent, so cotangent would be adjacent over opposite. And this is just that same 30, 60, 90 triangle. This time the angle here is 60 degrees. 60 degrees goes opposite the root 3. And so my radian answer would be pi over 3. In problem number 2, we're given an angle x, and we're asked what quadrant that angle lies in. How do I know x is an angle? Well, in an inverse trig function statement, inverse trig functions take ratios in and send angles out. So the negative 0.345 here is a ratio. The x, therefore, must be the angle. How do I know what quadrant I'm in? Well, it's all based on learning the restrictions of the inverse sine functions. What you have to learn and memorize about inverse sine is that it only knows about angles between negative 90 degrees and positive 90 degrees. That's it. It's never heard of any other angle. Well, I have a negative ratio here. I know that all the ratios come out positive in the first quadrant, but the sine ratio does come out negative here in the fourth quadrant. So x must be in quadrant 4. Letter B, now I have a cosine inverse statement. Cosine inverse works a little differently. It's only heard of angles between 0 and 180 degrees. Well, my ratio is negative. Again, all ratios are positive in the first quadrant, but I do know that cosine does come out negative. I'm using my all students take calculus mnemonic. Cosine comes out negative in quadrant 2. So x here must be a quadrant 2 angle. And then part C, the tangent inverse function. This one knows basically about the same angles as the sine inverse between negative 90 and 90. So I know I'm either in quadrant 1 or quadrant 4. Well, let's see, tangent ratios come out positive here and here, and I do have a positive ratio. So I'm not in quadrant 4, I must be in quadrant 1. You have to learn those restrictions in order to know where the angle lies. In problem 3, we just want to take those expressions and provide some decimal approximations in radians. So we'll go to the calculator. The first one is sine inverse of negative 0.345. I am in radian mode. Looks like that's equal to negative 0.3522. This is an angle measured in radians. It's a small negative angle, which means, just as we knew, it is located in quadrant 4. Okay, let's put in letter B. Cosine inverse of negative 0.55 comes out to be 2.1532. Let's see, does this make sense? Pi over 2 radians would be around 1.57. This is a little bit more than that, which means this angle is a little past pi over 2, which would put it in quadrant 2. So yes, this makes sense. Finally, part C, tangent inverse of 6 comes out to be 1.4056. That value is a little below 1.57, which means it's below pi over 2 and located in quadrant 1. In problem 4, we're doing a little bit of algebra review. We want to solve these equations, giving exact simplified answers. The first thing I'll want to do here is isolate the x squared, so I'll divide both sides by 27. 3 over 27 reduces to 1/9, and then I will square root both sides here. Remember, you always have two possible answers, so I'll include the plus or minus, and when I simplify that, this becomes x. I have plus or minus. The square root of 1 is 1, and the square root of 9 is 3. So my two final solutions here are positive 1/3 and negative 1/3. Letter B, I'll subtract the 5, and then I will need to divide by the 2. And then we're essentially at the same spot we were in the other equation. I'll square root both sides, including the plus or minus. Looks like I'll have two answers once again. This time square root of 1 again is 1. Square root of 2 is not nice. In order to simplify this, I'll have to rationalize the denominator. We've done this many times, and I'm going to end up with the two answers, plus or minus square root 2 over 2. Letter C, I'll add 5 to both sides, and then divide both sides by 3. And then at this point, you can basically stop. I can see that the next step would be square rooting each side, but you can't take the square root of a negative number. And so this is an impossible equation. This equation has no solution. Now you might remember I and imaginary numbers from algebra, but we're not doing that here. We're only looking for real solutions. This equation does not have a real solution. Letter D, when I add the 7, that wipes out that negative on the other side, so I think this one will have a solution. I get a 3 there. I'll divide by 8, so I have x squared equals 3/8. Go ahead and square root. Don't forget the plus or minus. And then this time, in terms of the simplifying, let's see, I'll have the square root of 3 on the top. The square root of 8 simplifies 2 root 2 because I can pull that 4 out. And then I will still need to rationalize the denominator with that root 2. And so what's that going to give me? Let's see, it looks like root 6 on the top. And then on the bottom, root 2 times root 2 is 2 times that other 2 would be 4. So plus or minus root 6 over 4. Finally, number 5, sine inverse of 3. If we tried to work that out on the calculator, we'd get an error. It doesn't exist. Why is that? Well, what is the 3? Is it an angle? Is it a ratio? It's got to be a ratio because it's inside the sine inverse function. The problem is the sine function itself does not have any ratios above 1. 1 is the largest sine ratio that exists. The same thing would happen if you tried to do sine inverse of negative 3. There is no negative 3. Negative 1 is the lowest, the smallest sine ratio that exists.